Okay, welcome everybody to the first lesson. If you're watching this, you're most likely an Algebra 2 student at Verdugo. So we're doing our first lesson, which is graphing square root functions. So I'm going to be putting up a series of these videos for Algebra 2 and other subjects as well. Just follow along what we're doing. Make sure you pause it. If you need to pause it, go back and rewatch whatever you need to rewatch. And at the end of the video, I'll give you guys a problem that you guys can do on your own. I won't be going over that problem at the end just because I want to make these videos as short as possible so they're easier to digest. So first things first, when we're talking about square root functions, a couple things you need to know before getting into this. Let's talk about square root. So if I were to say, what's the square root of 25? What I would want from you guys is 5. Okay, that is called the principal square root. Okay, so in this case, I'm not concerned about, well, I know, yes, technically the square root of 25 can be plus or minus 5. But for our purposes, if I say the square root of 25 for this graphing, I'm just going to want 5. Now, if I had said negative square root of 25, then you can tell me, well, that would be negative 5. But in this case, if I don't put a plus or minus here, just assume the positive. Just put a positive 5. So why is the square root of 25 5? Because 5 times 5 is 25. So with that in mind, what would be the square root of 4? That would be, well, 2. This should be review from algebra. Square root of 9. That would be 3, and so on and so on. A couple key ones to make sure people don't forget. Square root of 0 would be 0 because 0 times 0 is 0. And square root of 1 would be 1. Okay? And then if I were to say square root of negative 25, well, for our purposes here, depending on what your teacher has taught you, we're not going to say that that has a real solution there because 5 times 5 is not 25. Negative 5 times negative 5 is also not 25. So that wouldn't have a solution for us. Okay, so now we can get started with graphing a square root function. And we're going to start with the easiest square root function I could think of, the parent graph. So we're going to write f of x equals square root of x. Simple as that. Now I want to know what this graph looks like. Assume you've never seen this graph before. I'm just going to make a quick little grid here. Okay. Now, here's what I want to do. Just like any other graph, any other function, I need my x-intercept. I need my y-intercept. So let's figure that out. I'm going to go with x-intercept first. Well, if you remember x-intercept, what is going to be 0? What value is 0 for the x-intercept? It's going to be our y value. So I'm going to make the y value 0. And let's work it out. Let's see what happens. I don't think you can see that very well. So let's make the y value 0. Remember, f of x is essentially our y. So I'm going to make y0 equals square root of x. Well, that's great. I need to solve this. I need to solve for x. So let's think about this. What is the opposite, or in this case, the inverse of square rooting something? Square rooting something, the opposite would be to square it. What I do to one side, I'm going to do to the other. So essentially what that's going to do is that the square and the square root are going to cancel each other out. So I'm just going to be left with x equals whatever this is. So it's going to be 0 squared. 0 squared is 0 times 0. Yes, there we go. So our x-intercept is at 0, 0. And I'm going to go and immediately graph it. Something interesting about 0, 0. 0, 0, that means that it's x-axis at 0, 0, which is a very special intercept. Because if it's touching the x-axis at 0, 0, doesn't it also touch the y-axis at 0, 0? Well, let's see what happens. Let's see if that actually works. Okay, so now I'm going to go ahead and try to do the y-intercept. Okay, so I'm going to erase this part if you haven't copied that down already. Okay, now I'm going to do the y-intercept. So for the y-intercept, much like the x-intercept, this time, instead of the y being 0, we're going to set the x equal to 0. So let's bring that down here, except this time we're going to make the x equal 0. So f of x equals square root of 0. The x is 0. Well, we already know what square root of 0 is. Square root of 0 is 0. So f of x equals 0. And there we go. 0, 0. We already knew it. It's going to be right there. Both intercepts are right at 0, 0. Has to be. That's cute, but it doesn't really tell us much about our graph. Okay, great. It passes through that point. What else do we need to know? Well, let's continue here. For our purposes, what I want to do is I want to make a quick t-table. Okay? I want to make it quick just to get an idea of what this looks like. We're not going to do this every time. I just want to get an idea of what this looks like. So I'm going to make a quick t-table. And I'm going to ask myself, what do I want to plug in the place of x? Let's plug in something very easy, like 1. Let's do this mental math. You guys ready? Actually, this one I'll do without mental math first. F of x equals square root of, I'm saying x is 1. So let's do that. The square root of 1 is 1. So f of x equals 1. Done. What can we try now? And here's the thing. We're not going to try 2. That would be kind of dumb. Why? 2 would be dumb because if I were to put in 2, yeah, that's great. It has an answer, but I don't know off the top of my head what the square root of 2 is. It's going to be hard to graph because it's going to be a decimal number. So I'm not going to use 2. What I'm going to use instead for plugging into x is something that I know the square root of, that it has a perfect square root. So I'm going to do 4. Yeah, look at it. Look how easy that makes it. 4. Square root of 4 is 2. Oh yeah. I can go one step forward. Now I can do 144 if I want to, but who needs to deal with large numbers like that? Yeah, sure, the square root of 144 is 12. I don't want to graph that. So let's go easy. Let's do 9. The square root of 9. So if I plug in 9 for x, that'll give me 3. I have enough to graph now. Let's graph this. Okay. Let's now go to 1, 1. And then 4, 2. And lastly, 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't really reach 9. My graph doesn't go that far. So I'm just going to plot it. I'm just going to estimate where that is, somewhere like that. I think that's a good enough idea to see what our graph looks like. Now. And that should actually look familiar. If you remember from quadratics, graphing quadratics, our parabolas looked something like that. We had an AOS that went in the middle here. It was great. That is basically a sideways parabola. But remember, we weren't putting the negative values into this. So we end up getting a sideways parabola going towards the right. And so we get something that looks like that. It's about half of a sideways parabola going up. Now I want to check something here. I did say, this does say here it's a square root function. Those of you remember what a function has to pass the vertical line test. For example, a regular parabola, vertical line test passes, meaning it touches one time on that parabola. Whereas a circle would not be a function, because a circle, if you were to do a vertical line test, it fails. It touches it twice. Let's see if it passes the vertical line test. Yes, it does, because it only touches one time. Okay, so now I have an idea of what a square root function, this is the parent graph of the square root function looked like. Okay, so now that that's done, I want to do an actual, a more in-depth one, okay? So wait for video number 2. Video number 2, I'm going to be doing a slightly more complicated version of this.